Hello educators, I'm Daniel Mannion and welcome to our session on mastering calculator strategies. Today we'll demonstrate how to perform linear regressions using both the TI-84 Plus CE and Desmos. This guide is designed for teachers aiming to enhance their instructional methods and for students looking to improve their algebra understanding. Together, we'll explore how these tools can be seamlessly integrated into your teaching to enhance learning and understanding. In this session, we'll cover the process of conducting linear regressions using the TI-84 Plus CE, and Desmos. We'll provide detailed step-by-step instructions for each platform to ensure you can easily follow along and replicate these strategies in your classroom. Our focus will be on demonstrating how calculators can be used not only for computation, but also for teaching critical thinking and data interpretation skills. By the end of this tutorial, you'll be well equipped to guide your students through rigorous mathematical concepts using these technological tools. Let's begin with instructions on how to perform a linear regression for the TI-84 Plus CE. Beginning with step 1, it says turn on the calculator and access the stat editor. My calculator is already on, and now I'll press the stat button and select option 1, edit. This is where we can access our lists and where we will enter our data. So that's step 2, enter the data. Enter your x values in list 1 and enter your y values in list 2. For this demonstration, we'll use this data set from the table. I need to enter in 1 through 7 in the x column and all of these values in the y column. I'll go ahead and do that now. Okay, my ordered pairs are entered and I verified that everything matches the table that I was given. I'm now moving on to step 3, performing the linear regression. To do that, we'll press Stat, and then navigate right to the Calc menu, and scroll down to option 4, LinReg. Hit Enter. This takes us to step 4, setting up the regression variables. Specify L1 as your X list and L2 as your Y list if it's not already done by default. Ours is, so I don't need to change anything. You can adjust though, for example, if this said something different, for let's just say it was 8 for some random reason, then I can change that back by just pressing second and then 1 for L1 or 2 for L2. In this case, 1. Whoops, let me try that again. Second and then 1. Well, I'll delete that 1. There we go. Now, the next option we'll leave blank, and then for the next option, store regression equation, we can actually do that by pressing vars when your cursor's here. So vars, and then navigate right to yvars. We want 1 function, and then we're going to save our regression equation in that first y1 equation spot, but you could specify any location you want. So y1 for me, and then we'll scroll down to calculate, and we have our regression output. So step 5 is how do we interpret that? Well, the calculator displays the equation in the form y equals ax plus b, where a, right here, about -41, represents your slope, and b, about 337, represents your y-intercept. Continuing on, we can look at step 6, view the regression line on a graph. And so we could take this equation, since we stored it in y1 earlier. What I first want to do, in order to see that graph, is make sure that my stat plots are active. So I'm going to press second and then y equals to go to stat plots. Mine is already on. If I hit enter, I have the option to turn it off or on. Of course, I'll keep mine on. And then after that, we can press zoom. And I'm choosing option 9, zoom stat, to fit the graph to the data. And if we need to, you could press graph, but it already did it for us. And we can see our linear regression line and we can see how close it is to our data points. Now let's switch on over to Desmos to learn how to perform a linear regression here. Step 1 is to access Desmos. You can open Desmos either with your web browser or you can open up your Desmos app installed on your device. Step 2, we need to enter the data. So we'll click on the plus icon in the upper left hand side and we're going to choose table. This starts us in a column with x1 and a column with y1 values. We'll insert x values in the first column from our table, and we'll enter the y values in the second column from our table. I'll go ahead and do that now. Okay, my ordered pairs are entered into the table, and I've double checked that everything matches together. Now we'll move on to step 3, creating the regression formula. We're going to click, or we can click the plus sign again in order to start an expression, which will just take us down here, or you can simply click below your table. And we'll enter the regression formula using the notation y1 tilde m x1 plus b. Step 4. After entering the formula, Desmos automatically calculates and displays that regression line on the graph, but for us, we just can't see it. If you notice, that regression line has a slope of 16 and a y-intercept of negative 621, so we're going to need to zoom out a bit here. Here's our regression line, and you can see most of our points are up here. So I'll pan over and zoom in a little bit so that you can see that our line of best fit shows a pretty strong linear relationship, and I can back that up with our correlation coefficient because I see that it's 0.96, which is very close to 1, indicating that strong positive linear association. I'm getting a little ahead of myself. We were just on step 5, adjusting the view, and now step 6, interpreting the results. We've already reviewed the values of m and b, and those can be found here. Again, one more time, our equation would end up being y equals about 16.42, I'll round to the nearest hundredths, with a slope, plus, and actually I need to change it to a minus 621, approximately 0.83. Let's practice our new skill of performing linear regressions on the TI-84 and Desmos with 2 former Algebra 1 star problems. We'll begin with question 29 from the 2022 Algebra star, and I can look at the data analysis here and see that A will end up being the correct answer, and 62% of students answered this question correctly, which is a pretty decent percentage. As you can see, we don't have that little important topic question that LeadFord might designate. Without further ado, let's begin the problem. A construction manager is monitoring the progress of the build of a new house. The scatter plot in the table shows the number of months since the start of the build and the percentage of the house still left to build. A linear function can be used to model this relationship. And that does make sense. If I, try to draw my own line of best fit, I could, draw a line that gets pretty close to most of those points, headed in a downward direction. Okay. Now, which function best models the data? And I'm given 4 answer choices in slope-intercept form. Okay. Now, if I'm going to write a slope-intercept form equation, I know I need my data points and I can perform a linear regression. So I'm going to go to my TI-84 and do that now. So, to perform that regression, that's stat, option 1, edit. And I need to enter in this table into my list. Since I still have some old data in there, I could go up and press delete or clear and press enter, and that would delete that one column, but I know this means I have some other data in some other programs or functions that I just want to completely clear. And if you aren't familiar with resetting the RAM, I'm going to go ahead and do that now. So that's second memory, or the plus sign, option 7 for reset, option 1 for all of the RAM, and option 2 for reset. So my RAM is cleared, or the random access memory. So when I go to my list now, no data is there, and in no other part of the calculator will you see data as well. So that means I can now enter in my data. I'll go ahead and do that quickly. Alright, with my data entered and double checking that the data I entered matches the data that I was given, now I can perform the linear regression by pressing Stat, navigating right to Calc, and then I'll press option 4 for linear regression. My L1 and L2 list are by default where I need them to be, and I can store my regression equation, but I don't need to in this instance because I'm just really only looking for the equation. So I'll move down to calculate, and that equation that was given to me is y equals about negative 13.5x. So I can see that's already matching my top two answer choices, and then with a y-intercept of about 97.8, and that best matches answer choice A, which of course matches the answer key here. Our second problem today is question 12 from the 2018 Algebra 1 STAR exam, and you'll notice that this is an important question to talk about. Based on the data analysis, 51% of students answered this question correctly. I believe the drop in percentage points in a question like question 29 versus question 12 is due to the fact that this question isn't asking for just like what does the linear regression model tell you, like what is that equation that best matches the data, but this one asks you to go one extra step and to find that equation first and then use that equation in a future prediction. And so we'll walk through that process now. To begin, it says, a zookeeper recorded the feeding schedule for a baby rhinoceros for 20 weeks. The table and scatter plot show the percentage of the baby rhinoceros's body mass that was used to determine the amount of food given at each feeding as a linear function of its age in weeks. So we're given this table and the scatter plot. What is the best prediction of the percentage of the baby's rhinoceros's body mass? So we're trying to get a y value that should be used to determine the amount of food given at each feeding when it is 25 weeks old. And so that's weeks. So I know I'm given an x value and I want to know my y value. So in order to do that, first we'll write the linear regression, or perform a linear regression to write the equation. Then we'll use that equation to input x to get an output of what our best prediction for that y value should be. We'll go ahead and start that process on Desmos by adding a table, and then I'm going to input the data. Alright, my data is in the table, and now I'll perform the linear regression by typing in the equation y1 tilde mx1 plus b. And so down below I can read that my slope-intercept equation will be y equals, or approximately y equals, negative 0.54 is what I'm going to round that to, x, and then I need plus b, which is approximately 19.8. Alright, now I want to also see where those equations are here in my graph. Next up, I have my equation and I want to make a prediction. So given this x value of 25, I can now type in an equation which simply inputs negative 0.54 times 25 plus 19.8, and you can see Desmos automatically solves that as a value of 6.3. And if I'm looking for the most reasonable answer that's closest to mine, 6.3 is closest to G. In this case, not only did students need to find a linear regression, but they needed to use the equation from that regression in order to make a prediction by using their input to get a future output value. Today, we explored how to perform linear regression using both the TI-84 Plus CE and Desmos. We meticulously walked through each step on both platforms and applied these techniques to realistic datasets. Our discussion highlighted how calculators can serve as significant aids in teaching and understanding statistical concepts, allowing students to visualize and analyze data effectively. I hope this session helps you feel more confident in integrating technology into your math lessons to enhance student learning. Thank you for joining me in this tutorial. I encourage you to practice these techniques with your students using different data sets. Engage them with tasks that require analyzing and interpreting data, which will, of course, enhance their understanding of linear relationships and strengthen their statistical reasoning skills. As always, keep exploring these tools to make math learning more engaging and effective for your students. Thanks for watching, and happy teaching.